Hello, this video is intended for Math or MTHE 272 students. It's going to focus on the project element of the course, introduce the 3 project options, and describe the process we'll go through to complete those projects by the end of the course. First off the bat, there are 3 project options. You only need to select one. The idea is pick the one that interests you most or seems like has the flavor of calculation or of application that appeals most to you. The first option for the design projects is going to be a tower-shaped truss, so a tower that's going to be made out of joints and beams. And the goal there will basically be to maximize the strength of the truss under certain conditions. We'll gradually expand the options you're allowed to explore in terms of the structure. The core skills that are needed with that, as we've seen earlier in the course, is solving linear equations, but we're going to add something new that is going to be covered around week 9-10 of the course, which is optimization, numerical optimization. There will also be a surprising amount of bookkeeping, just trying to track how the geometric locations work out in terms of the strength of the beams. The second project option is going to be focused on cooling and heat flow. There's going to be the idea of designing a surround for a pipe to maximize the distribution of heat to the environment. And again, that's something we've seen before, and the challenge will be to handle more complicated scenarios than we handled earlier in the course. Finally, the third design option will be to design a roller coaster, and this is going to involve changing the geometry of a roller coaster so that a car launched down the track will hit some target or go the furthest distance, other kinds of quantifiable measures like that. And it's going to involve, obviously, interpolation to build a smooth track, and 2 new topics in this one that we haven't quite seen yet. One, solving differential equations. So think back to Math 225, but we're going to do it in a totally different way. And optimization again, so some way to tweak the structure automatically or have MATLAB do the heavy lifting to optimize this truss or optimize the track to achieve some goal. So how does this actually roll out? There are several stages along the way. There are 2 phases that are basic programming, phase 1 and phase 2. The idea here is just to deliver some functions in MATLAB that do a certain job, and these will be completely specified. I'll give you sample inputs and sample outputs, and your function basically is supposed to join those 2 together. The next major submission is going to be an animation challenge. So creating some code that will actually demonstrate through an animation various design scenarios. And finally, there will be design challenges. So for each project option, there'll be 3 design challenges you can tackle, and only 2 of them have to be done, but you can choose to do all 3 if you like. This project is definitely meant to be done in groups. I think it's easier to manage. Groups can be up to size 4. If you desperately need to work with 5, you can do that, but honestly, you'd be better off working as groups in 2 and 3. It simply becomes unwieldy to manage more than 4 people in a group. That being said, groups do not need to be the same for each stage. So if you're finding things aren't working well with one group, you can certainly rearrange without needing to get permission for the later phases. The main identifier I'm going to use to tell you all apart is your net IDs. You're going to have to know your colleagues' net IDs. Historically, I found that a lot of students can't seem to spell each other's names right, so net IDs tend to be a bit more robust. If you're having, or you don't have a group already made, or that you've sort of scoped out, then I'll create a Moodle discussion board called Project Group Partnering Forum, and that'll be an opportunity to say, or to announce what project you're interested in, what kind of skills you can bring to a team. There'll be more details on that actually in the forum. So the idea is, get a group together, at least for the first phase, see how it goes. If it's working well, by all means keep the same group throughout the course. If it's not, then feel free to exchange and look for other partners. The grading on the project itself is going to be out of a total of 60 marks. Out of those 4 submission aspects, there's 20 marks for phase 1 and phase 2, the basic coding steps, 10 more marks for the animation challenge, and the other half of the project is going to be graded on the design tasks, so how well your designs perform. Specifically, phases 1 and 2, these are straightforward marks to get. If you submit on time code that does the right job, and that'll be clearly specified, you get 100% for that phase. I will allow early submissions, so if you want to test whether your code will get 100% or not, I'm happy to tell you that ahead of the deadline. The animation challenge is going to be marked on accuracy and correct modeling. So, is your animation clearly representing reality, or the physics underlying the simulation or not? And then also for specific features in the animation. Is it interesting? Have you added some worthwhile annotations to it to make it easier to understand as a viewer? Finally, the design challenges are going to be marked on competitive ranking of the designs. So here it's going to be design a tower, design a track, or design a cooling fin to certain specifications. The design that does the best gets the best mark. So this is a pure design challenge setup. Now, the project does not just stop at the end of the project. As a motivator for everyone in the group to be involved and to understand the steps, the final exam is going to be written on a computer, as I mentioned at the beginning of the course, and more importantly for the project tie-in, 40% of the final exam is going to be a recapitulation, a micro example of your project. So again, you'll have a choice of one of 3 project questions on the exam, and yeah, I'll give sample questions in advance, but it'll basically be a recapitulation of the design task from the project. So make sure, even if you're not the primary coder in your group, that you understand what's going on so that when the time comes, you can succeed on the final exam. Just in terms of scoping out timelines and when this all be due, they're outlined on the screen before you here, but basically week 8, so a couple weeks after reading week, we'll have phase 1 due, and the next week or 2 after that, phase 2 will be due. So those are all the functions that'll be core, and you'll need those to do your animation and design challenges. And then weeks 11 and 12 is when we'll set deadlines for the animation challenge and design challenges. So that's the main structure for the design tasks and the design project in the course. If you have any questions, please bring them to class after reading week, and I'll happily take them up then. Otherwise, I'll wish you a good reading week, and we'll see you in about 7 days. For the individual projects, I'll make 3 separate videos describing loosely the flavor of the challenges for each of those design options: truss, cooling fin, and roller coaster.